Okay. So let me start now. So I was talking about optimal binary search tree, correct? So what is the problem definition here? You have given n keys, right? You have given n number of keys, starting from A1 till AN, A1 less than or A2 or whatever. So that is what 10, 20, 30. A1 should be less than A2 should be less than AN. And the probability or the frequency of all these keys is also been given. You need to find the BST with a minimum average number of comparisons in a successful search, correct? In a successful search, we are going to find a BST. So since the total number of BSTs which is required with n node, we already told a combination of 2n and n divided by n plus 1. So which usually grows exponentially. So we require more number of comparisons, all those things. So instead of doing that, we are going for an algorithm. We are going for an algorithm to constructing it. Okay, we'll see how it works. Okay, so okay, this it's already been explained. So now we'll go for the problem. So here in this problem, what happens is a key has been given. Okay, I already told a set of keys has been given. Consider this is an example set of keys. Do, if, int, while is an example keys. Now I will represent these with different vertices. So 1, 2 numbers. Okay, 1, 2, 3, and 4. Okay. So 1, 2, 3, and 4, I will represent it. Then probability of all these keys is also been given. So 0 0.1, 0 0.2, 0 0.4, and 0 0.3. Clear? So this is a problem given. Now what I need to do, I need to find out the optimal BST. Correct? OBST. I need to find out that. So what is your first step? You need to write down. So A of I is set of keys. I will, instead of writing do, if, int, while, I will get confused. So I'll write 1, 2, 3, 4, numbering it. So P of I is a probability. So 0 0.1, 0 0.2, 0 0.4, and 3. Correct? So you can either represent this in this way, or you can just write the a table format. That is also fine. Okay. So no need to get confused why I need to write only this. Okay. Why you need to write only this is here is because if you start solving all the other values, whatever you are getting here, you will not, it will not change, and it will not help us in any way. So that is why only this much is more than enough. Correct? So start with a diagonal. Okay, start with a diagonal, and the upper part, only these part is sufficient for us. So represent it in this form. Okay, and here you make a note here. If consider in the question we have given 4 vertices, but here we require n plus 1. Okay, so 1, 2, 3, 4, and 5 is required. Okay, here also 5 columns is required, but it should start with 0. Okay, this point should be please make a note of all these points, because it is very important. So you should remember this. Correct? So what you should remember, I need to write a cost. This is called as cost table. I need to write a cost table here. The each and every row indicates the ith value. J here, that is a column, indicates the column indicates the jth value, I and j. And all the rows should start with 1 till 5, and here also it should, but here it should start with 0 to 4. Is it clear? And you should have a root table. What is this root table? Which basically talks about the roots. What is the root between 1 and 1? What is an intermediate root? All those things. Okay, we'll see how it works. So same thing here you represent, but in a root table, you just make a note of only the vertices which is given in the question: 1, 2, 3, 4, and even in the row column wise. So 1, 2, 3, 4 is sufficient. But while writing a cost table, please remember it should start with 1 to 5 for all the rows. For all the columns, start with 0 to 4. Clear? So there are actually a few steps here. Please make a note of this. C of, that is a cost of I comma I minus 1 is equal to 0. Consider I want to do the I want to write the cost for 1 comma 1. Cost of 1 comma, okay, cost of 1 comma, not okay, 1 comma 0. Fine, 1 comma 0. So here 0 is what? 0 is not 1 comma 1. 1 comma 0. Or will I get 0? 1 comma minus 1. Correct? So that you will get a value as 0. Okay, so let me just write and show you. Here what I'm talking about here is, suppose I want to find out the cost of 1 comma 1. These 1 comma 1 I can represent it with, 1 comma 0. 1 comma 0 I can write down like this, correct? So C of 1 comma 1 minus 1. So this formula holds true for the C of 1 comma 0, correct? So if you have such cases, simply write 0. Okay, simply write 0 in a cost table. Okay, so what I was saying here is, so go to the previous example. So here I comma right here, so 1 comma 0, 2 comma 1, 3 comma 2, correct? The I value is I value, and the jth value should be 1 less than the ith value. So 1 comma 0, 2 comma 1, 2, 3 comma 2. I hope you understood this, right? So or else I can also say I comma j minus I minus 1, correct? That is what I wanted to tell you. I comma I minus 1. So if the value is if it is so, then you simply represent it with 0, or that is a formula. Or what you should do is blindly write zeros for the diagonal. Okay, the middle one, the diagonal, just blindly write the 0. Or if you derive using this formula also, you will get 0 always. That is the first condition. Second condition is C of I comma I, which means C of 1 comma 1, C of 2 comma 2, 3 comma 3. Write the probability value as it is. So here the example, C of 1 comma 1, what is the probability of 1? It is 0.1. So I have written C of 2 comma 2, the probability of 2 is 0.2. C of 3 comma 3, C of 4 comma 4, similar way. Clear? So this is the next condition. For the remaining values, correct, for the remaining which has been left out here, how will I fill it? Using these formula, third one. So C of I comma j is equal to minimum of I should be less than k, and k should be less than j, correct? So using this formula, C of, please remember this, otherwise it is very difficult to solve a problem. So C of I comma k minus 1 plus C plus, okay, C of k plus 1. So here it is k minus 1, here it is k plus 1 comma j. Okay, so minimum of this plus the probability from I to j. Okay, remember, yes, is from I to j, probability of PS. So we'll see this with an example, but you remember this formula. The one simple way is C of I year, j year. In between, what you should write? K minus 1 and k plus 1. Okay, that you remember. So while solving problem, we'll go through this with each and every step. Okay, so this is what I was talking about, I comma I minus 1. So 1 comma 0, 2 comma 1, 3 comma 2, everything is 0. So this table is, I mean, this diagonal is filled it with 0. So even this is with probabilities. Fine. So we'll go for the third one. So the remaining is what? So and one more thing you should remember here is, I should start with a diagonal, start filling with a diagonal. So if I talk about the diagonal, so the next one is 1 comma 2, fill this one. Okay, next is 2 comma 3, don't go for 1 comma 3, fill this with respective to the diagonal, then only you will get the value. So 1 comma 2, fill it out, then go for 2 comma 3, then go for 3 comma 4, then go for meaning. Okay, so fill it out with diagonals starting from the left to right. So what is the next one? It is 1 comma 2. How will I get 1 comma 2? Correct. 1 is what? I. J is what? 2. According to this formula, I and j. Correct. So what is the formula? Minimum of C of I comma k minus 1, k of C of k plus 1 comma j, and summation of this is the formula. Correct. So what is the possibilities of k here? Find the possibility of k here is, it is between the range, okay, 1 and 2. So I can have 1 and I can have possibilities. I can have k as 1, I can have k as 2. K here basically represents the what you can say, the intermediate value. Okay, the root node, I can say, talk about the k value usually represents a root node. So now I can have 2 as a root node or 1 as a root node. So minimum of these I need to identify. So k is equal to 1. If I use k is equal to 1, okay, observe this. So C of I, you know, it is 1, so it is 1, correct? So I is equal to 1, so 1 comma k is what? I am considering 1 in the first case. So 1 minus 1 is 0 plus C of 1 plus 1, correct? Because k is 1 here, so it is 2. J is what? J is 2. Clear? So C of 1 comma 0 plus C of 2 comma 2 plus summation of S is equal to 1 to 2 and PS. So it is P1 and P2. Correct? Probability of first one and second vertices. Is it clear? So now you just go to the previous one and check it out. What is C of 1 comma 0? So if I want to go back, okay. So C of what is the value which is required? C of 1 comma 0. C of 1 comma 0 is what? C of 1 comma 0 is 0, correct? So that is why it is 0 here, plus C of 2 comma 2 is 0.2, so it is 0.2, plus probability of the first one is what? Probability of okay, where is the problem? Okay, probability of the first one is 0.1, second one is 0.2, correct? So 0.1 and 0.2, so you will get 0.5. Clear? I hope this should be clear. So next one is k is equal to 2. Again do it for this. So C of 1 comma 1, so plus C of 3 comma 2, because k value is 2, so 2 minus 1 is 1, so 2 plus 1 is 3. I hope this is fine, right? So plus the same probability you can use it here, 0.1 and 0.2, you will get 0.4. Minimum out of this is what? 0.5 and 0.4, minimum is 0.2, correct? So if you observe here in the root matrix here, I can, okay, I didn't tell about root matrix, I will tell you. So what is the value which he got here? 0.4, the minimum value 0.4, correct? So now I can write 0.4 here in this, okay, 0.4 here. So there I can write 0.4. And what is the value which you got here? Okay, so what is the value which you got? The value which I got, the root value which I got here is k is equal to 2. So write down 0.4 and k is equal to 2. So 1 comma 4, right? So okay, just make a note of here. So 1 comma 4 here in a root table, write down it as what is the value which we got? 2, correct? So I don't know where it is a table. Yeah, here is a table. So 0.4 here I got 1 comma 2, correct? So 1 comma 2, the cost table is 0.4, and in the root table it is 2. And initially I also forgot to talk about these, right? So you need to fill root table also, the diagonal value, which means the root of 1 comma 1 is 1 itself, 2 comma 2 is 2 itself, 3 comma 3 is 3. Root I'm talking about, correct? Because there is no other root existing, the vertex is existing, correct? So 3 comma 3 is 3, 4 comma 4 is 4. And we, in the first step, we got this also, correct? K value as 2. So here simply write down the k values, whatever you got the minimum value. 2 we got in the first one. I hope this you understood, correct? So we have done with 1 comma 2. Next, what you should do, you have done with this. Next, we need to go for this diagonal. So 2 comma 3, I need to do it. So 2 comma 3, what is the possible values of k? K value is 2 and 3. So k value is 2 and 3. Again, use this formula, you will get some values. Minimum out of 1.0 and 0.3 is, 0.8 is 0.8 is a minimum. So 0.8, I can write it for 2 comma 3. So I have written, so 2 comma 3 value is 0.8. Clear? And what is the value of k you got? K I got the value as 3. So I have written here 2 comma, with the, in the place of 2 comma 3, I have written 3 also. Clear? So this is done. Next possibility is what? Okay, we have done with 2 comma 3, correct? So we have done with 2 comma 3 also. Next is 3 comma 4, correct? So next is 3 comma 4. Possible values of k is what? 3 and 4. Again write down 3 comma 4, 4 comma 2, and probability of 3 and 4. Get the value. Again do this. The minimum out of this is what? This is a minimum. 1.0 is a minimum. So for the possible value is 3. So 3 comma 4, I can write the value as 1.0. With the k value I got as 3. So 3 comma 4, I got the value as 3. Correct? So we have done with this also. Next left out is what? 1 comma 3, 2 comma 4. Correct? So how will I do 1 comma 3? If you observe here, possible k value is what? 3 values within this range, 1 comma 2. Possible value is 1, 2 and 3. Clear? Now do it again for all these things. Check for the minimum. Minimum is 1.3 with k value. We have done with this. Correct? So we have done with this. So represent this in the table. I got the value as 1.1 as a minimum. Write down here. and k value I got 3. Now I need to do for 2 comma 4. So for 2 comma 4, you will get again 3 values, 2, 3 and 4 as a k value. So write down minimum value, consider the minimum value with these formula and write down. And one more thing you should make a note here, even these probability number is changed within this range. So 1 comma 3 possible probability is what? P of 1, P of 2 and P of 3. 3 probabilities you are adding, but in the previous one only 2 probabilities you are adding, because we are considering only 2 k values, correct? That you should remember. So this is done, and now we are adding P of 2, P of 3 and P of 4. First, last, the next 3, leaving first one, next 3 we are adding probabilities. Okay. So this we got minimum is 1.4 for k is equal to 3. So minimum is 1.4 with the root as 3. Clear? So once this is done, the next left out is 1 comma 4 is 4 only. So 1 comma 4, what is the possible values? 1, 2, 3 and 4. Again do it for everything. Minimum is 1.7. I have written here. So only thing you should remember here is this formula, correct? And the main thing is the probabilities. How many number of cases required within the range you need to remember. The minimum value you make a note here in the cost table. In the root table, write down the k value. Clear? In the root table, write down the k value. I hope this is clear, right? So this is all about filling the table. Once you have done, our main aim is what? Our main aim is to create a BST. Correct. So how will you do the BST? Is your next question. What is the first one? The last value which you got here is 1 comma 4. Is it 1 comma 4? Yeah, it is. Yeah, it is for 1 comma 4. We computed for 1 comma 4. So we started with 1 comma 4 here. Okay, with 1 comma 4, what is the root you got? The value you got here is 3. Correct? That you remember. Okay, and what you need to do here is, again you need to do for it is something like this. There is a formula here in order to do this. R of I comma k minus 1. Okay, R of I comma k minus 1 is at the left hand side. Left hand side, and k plus 1 comma sorry, k, I think it's k comma k comma what is that, j value, k comma j is at the left hand side. Okay, so if you look at this diagram here, k value, what is the k value which you got for 1 comma 4? 1 comma 4, the minimum is 1.7. K value I got is 3. Correct? So 3 minus 1 is what? 2. So 3 minus 1 is 2. So 1 comma 2, this is at the left hand side. Right hand side is what? K plus 1. K value I got as 3. So 3 plus 1 is 4 comma 4. So these possibilities are there, right? I hope this is understood. Is it clear? So this is one step. Next is 1 comma 2. Go to 1 comma 2. 1 comma 2. Where is cost of 1 comma 2? It should be somewhere here, right? So 1 comma 2. What is the value you got? 0.4. What is the value of k you got? 2. Correct? So 2. K is equal to 2 you got. So in the left hand side, what you should do? 1 comma 2 minus 1 is 1, and here also you should write 3 minus, sorry, what is the 2 plus 1? It is 3 comma, okay, but if you observe, there is no 3 comma 2, correct? If you see here in the table, there is no 3 comma 2, so that is why there is no right child here. Clear? So that you should make a note, and this is also done. 4 comma 4, again check for 4 comma 4. There is okay, 4 comma 4 is already 0, which indicates it's not required. Correct? Okay, k is 4 comma 4, which indicates it is not required. So I'm not going for any further sub tree for that. Correct? So this is clear, I hope. So what you should do here is write down the respective roots. Okay, this is a tree which you got. Okay, for this write down the respective nodes. So 3, so this is 3, and this is 2, and this is 1 and 4. So something like this: 3, 2, 1. Okay, and for this it is 4. Okay. According to the given question, 3, what is the value for 3? The value for 3, I mean, it is something like this, right? Where is it? Problem? Yeah, here. So this is represented with 1, 2, 1, 3, 4. So I will get a tree something like this, correct? I will get a tree something like this. So int, then 2 is what? 2 is this, right? So 1, 2, 3, and 4. So 2 is if. Within this again I have a right left child, that is do. Here I will get while. Okay. So this is our optimal binary search tree. Clear? So I hope I was very fast because of time limit, but you should, I hope you got all these points. Okay. So now let us discuss. This is all about optimal search tree. We'll go for the algorithm here. Okay. In this algorithm, we'll see an array. We will give an array with the probabilities also, with the set of keys also. We need to find out the average number of comparisons required here. Correct. And you need to find out the table, optimal BST. What is the condition here? I starts from 1 to n. This I already told. In a root node I comma I, initially make it with I. C of I comma I is P of I. C of I comma I minus 1 is 0. That is what we did here, correct? Then C of n plus 1 comma n is usually 0. Okay, n plus 1 comma n, that is, I talked about this also, right? N plus 1, that is, say for example, 4 plus 1, something like this. So 4 comma 5 comma 4, this one. So 5 comma 4, n is 4, so 5 comma 4 is also 0. That is what is this. So for D, starts from 1 to n minus 1, what you need to do, diagonal count. We are going for a diagonal count from 1 to n minus 1. So that is why we require one more if loop. So for I is equal to 1 to n minus D, correct? We are doing it for diagonal. So these two for loops, there is a change n minus D, and D is 1 to n minus 1. So what you are doing, J is equal to I plus D. Okay. And what you are doing here is checking for the minimal value. So C of I comma k minus 1 plus C of k plus 1 comma j, the minimum out of this will be kept. And the k mean value, the k value, you are placing it in k min, and everything you are making a note in a table, the cost table and the root table you are returning. Okay. Is it clear? Any doubts here? Now I will stop this class because we have done with optimal binary search tree. Now we'll discuss how to do it.